So what we're dealing with now is a dilution of a solution, which basically involves taking one solution at a high concentration, adding water to it, and taking it down to a lower concentration. This would be like watering down your antifreeze. This would be like watering down a can of pop, things like that. The reason we need to worry about these kind of calculations is because in chemistry and in science, when we order chemicals, they get shipped to us in the highest concentration possible, and it's up to us on the end to dilute them down to the desired concentration. For example, sulfuric acid would be shipped to me at 18.0 molar, 18 moles per liter. At that concentration, if I was to spill any on my skin, it would instantly burn. Maybe not all the way through, but I would definitely have a nice open wound from that. So obviously it's not safe to use, so I need to be aware, and you need to be aware of how to actually calculate it to mix this down to a concentration that is useful, but also not harmful. The most complicated piece about these type of calculations is determining what is the initial condition and what is the final condition. The initial condition is our highly concentrated solution, and the final condition is our diluted solution. So reading the whole question and getting an understanding of it before we start to define variables is quite important. What volume of concentrated sulfuric acid is required to prepare 5 liters of 0.015 molar solution? Thinking about this and using some common sense, our end game of this is having 5 liters of 0.0150 molar solution. So that's our final condition. Those are the 2's. Our V2 being 5 liters, and our M2 being 0.0150 molar. Leaving us knowing that our 18.0 molar would have to be our initial, our starting concentration at M1. And what volume? Obviously that's a V, that's V1 that we need to find. So going to the dilution equation, where M1 V1 equals M2 V2. Substituting in what we know, M1 is 18.0, V1 we don't know, M2 0.0150, V2 is 5.00. On the right, we can actually calculate that out. Gives us 0.075. Last step to find V1, we need to divide by 18 on both sides. Giving us V1, and we're going to take this to 3 sig figs, equals 0.00417, and volume, in this case, is measured in liters. That's a perfectly fine answer, perfectly acceptable, 100% correct, but we generally don't find measuring devices that measure to 5 decimal places of a liter. A more useful measurement of volume in this case would be milliliters. And to convert liters to milliliters, again, this is not necessary, but it could be useful, especially if we're doing this in a lab situation. To convert liters to milliliters, we multiply by 1,000, so that would give us 4.17 milliliters. Very, very small amount, but actually still quite powerful when we mix it up.